Hello everyone. Today we are going to see about the topic implementation of MLP for a non-linearly separable data. The objective of the experiment is to implement a perceptron for classification using Python. Introduction. In this experiment, we will explore a basic implementation of a neural network using Python. The code provided demonstrates how to create a simple, feed-forward neural network that can learn to classify binary inputs. We will break down the key concepts, code structure, and provide detailed explanations of the code examples. Key concepts. Before diving into the code, let's clarify some fundamental concepts. Neural network, a computational model inspired by the way biological neural networks in the human brain process information. It consists of layers of interconnected nodes. Forward propagation, the process of passing input data through the network to obtain an input and output. Back propagation, a method used to update the weights of the network based on the error of the output. Activation function, a function applied to the output of each neuron to introduce nonlinearity. In this case, we use the sigmoid function. Let us see the code structure. The code is structured into several key components. First, inputs. Necessary libraries such as NumPy and Matplotlib for numerical operations and plotting. Data initialization. Input data X and target output Y are defined, along with the network's architecture parameters. Weight initialization. Random weights for the hidden and output layers are generated. Forward propagation function computes the output of the network. Back propagation function calculates the gradients and updates the weights. Training loop iteratively trains the network by performing forward and backward propagation. Prediction function uses the trained weights to make predictions on new input data. Here is the provided code with explanation. Here it is the mod is imported. It is input data and target output. Network architecture parameters with the number of input features, output neurons, hidden neurons, number of training examples, and learning rate. The weight initialization area, where the weight matrix for hidden layer, weight matrix for output layer, and to store loss values. It is the sequence activation function, forward propagation function, with linear transformation for hidden layer, activation function for hidden layer, linear transformation for output layer, activation for output layer, and back propagation function. And it is the training loop and plotting the loss over iterations, and it is the prediction function, and it is testing the model with different inputs. Explanation of key sections. Weight initialization. The weights are initialized randomly to break symmetry and allow the network to learn effectively. Forward propagation. The forward prop function computes the activations for both the hidden and output layers using the sigmoid activation function. Back propagation. The back prop function calculates the gradients needed to update the weights based on the loss. Training loop. The network is trained over a specific number of iterations, updating weights and recording the loss at each step. Prediction. The predict function evaluates new inputs based on the trained weights, providing binary outputs. Applications of the multi-layer perceptron. Here are some of the five basic and important applications of multi-layer perceptron. First is image recognition, used in tasks like handwritten digit classification and basic object recognition. Second, natural language processing, applied in sentiment analysis, text classification, and simple language translation tasks. Financial forecasting, useful for stock price prediction, credit scoring, and risk assessment. Healthcare diagnosis, employed for disease prediction, analyzing patient data for outcome forecasting. Recommendation system, powers product and content recommendations based on user behavior. MLP's flexibility makes them foundational for varied machine learning applications. Thank you.